Okay, welcome to Unit 3. This unit is going to cover transformation of functions, how we look at functions and we change them somehow. Day 1, transformation of functions, we'll just deal with how we change them on graphs. So we're going to look at graphs. So if you recall what a function is, we use f of x as a function notation. A transform function is going to have these four of the letters with it. G of x is equal to a times f of parentheses bx plus c close parentheses plus c. So there are four transformations that are possible. Our four transformations, we have to look at the letters that are being used here, and I would say A and D are on the outside of the parentheses, or outside the function. That means it is a vertical idea, and that means it's going to affect the y values. It's affecting the function, the y value of the function, a vertical idea. And conversely, B and C are in the inside of the parentheses. It's going to have a horizontal effect because the x-axis is horizontal, and that's inside, and it affects what happens with the x values. A and D are on the outside of the function, and B and C will usually be inside of parentheses with the letter x. So let's see what the four letters do to functions. So first we're going to look at the letter A, and when the letter A is bigger than 1, like 2 or 3, it is a vertical stretch. It's going to make the graph vertically longer, higher, bigger, going up and down. And when A is smaller than 1, like a half or a third, it is a vertical compression. So it's smaller vertically. And when A is negative, it is a reflection over the x-axis. So in other words, positive y values become negative y values, and vice versa, negative y values become positive y values. So really all we're doing is going to multiply the y values of a function by a, whatever a is. If a is 2, we multiply all the y values by 2. If a is a half, we multiply by a half. Okay, the letter B is a little bit trickier. And the key with the letter B, because anything inside of parentheses, we're going to not really use B, we're going to use 1 over B. So f of 2x is not, I'm not really going to use 2, I'm going to use a half. So I'm always using the reciprocal. So when B is bigger than 1, since I'm using something bigger than 1 like 2, I'm actually using a half. It's a horizontal compression. So horizontally, the graph is getting skinnier. And B is smaller than 1, like a half. Well, 1 divided by half is really the number 2, so this is a horizontal stretch. And when B is a negative value, it is you're going to reflect over the y-axis. So in other words, positive x's become negative x's, and negative x's become positive x's. So what are we really doing? We are going to multiply all the x values by 1 over b, not the b value. We're using the reciprocal, because anything inside the parenthesis letter x, we use the inverse of which we see, and I'll get to that in a minute. Okay, the letter C, we got to be careful here. We're actually going to use the opposite of C, okay, because what I just said earlier for both of these, we use the inverse of what you see. We don't use B, we use the inverse, which is 1 over B, because it's multiplying. And instead of plus C, we use the opposite, minus C. So when C is bigger than 0, that means I may have a positive value. I'm actually using negative C, so it would be left C spots, and a negative C, which means I would really be using something that's positive. That would be right C spots. Okay? And that's if I just have the letter C. But what happens if B, let's say I have a number in front of the X, that's not 1, because right now B is equal to 1. That means B is going to change, so I'm going to use the opposite of C over B. This is a big deal. Let's do an example. F of 2x plus 6. Well, opposite would be negative 6 over 2, which is equal to negative 3. That means I would be left 3 spots. Okay, you say, well, it's negative. It should be right. I go, no. I've already incorporated the negative by doing the negative C business. So this is left 3 spots. Okay? By me putting the negative into C, I'm incorporating the negative idea again. I don't take the negative of the negative. That's undoing what I just did. And finally, probably the easiest one out of them all is this idea of D. When D is positive, I go up D units. When D is negative, I go down D units. Okay? A and C are really easy. What you see is what you get. B and C, you have to be careful. You have to kind of use the inverse of what you're doing. So my summary on the next page is I'm going to do all 4 things, and I should do them in order. The letters A, B, C, D. Particularly, A and B have to come first because they are multiplying of X and Y values, and C and D are really adding or subtracting to X and Y values. So multiplication always comes before addition. And so I've got to make sure I do that first, and make sure when you use a C and there's a B value, you're using that. So let's try some examples here. My first example is this function. I'm going to make it a little bit bigger. And I should always identify the parent function. That's why I made you do that homework that was due today. The parent function is the absolute value of X. And the absolute value of X looks like this V graph. Goes through 0, 0. Goes through 1, 1, and goes through negative 1, 1. And I'm going to draw this lightly here in gray, just to give some precision. And you can see I have 0, 0, 1, 1, negative 1, 1. I also have the point 5, 5, negative 5, 5. I could put a bunch of points on there. What are my transformations? Well, if I look carefully, I have an A value, I have a C value, and I have a D value. The A transformation is a reflection over the x-axis. Okay. The C value is minus 3, but the opposite of it is plus 3, so that's right 3. And my D value is a plus 1, which means up 1. So I'm going to take every dot on this original graph. I'm going to do the A, C, and D in that order. I'm going to reflect it over the x. I'm going to go right 1 and up, right 3 and up 1. So this point 0, 0 flipped over the x-axis doesn't move. So I'm going to go right 3, 1, 2, 3, and up 1. And now here's a new point here at 3, 1. The next point here at 1, 1, I'm going to flip it over the x. So I'm over here now. I'm going to go right 3, 1, 2, 3. I'm going to go up 1. So right now I'm at 4, 0. And this point here at negative 1, 1, I'm going to go flip it over the x, which is down here. I'm going to go right 3, 1, 2, 3, and up 1, and I'm right here at the point 2, 0. And if I want to take negative 5, 5 and flip it, I'm down here at negative 5, 5, 1, 2, 3, up 1, and 5, 5 becomes 5, negative 5, and 1, 2, 3, up 1. And I could draw this graph, and I'm doing the best I can with the stylus, and there we go. There is that graph. Okay, does it look like it's been reflected over the x-axis upside down, right 3 and up 1? And the answer is yes, it does. The next graph, well, let's see. I should always start with the parent graph, and the parent graph is the square root of x, and the square root of x, again, you should know, kind of looks like this. It had points 0, 0, 1, 1, 4, 2, stuff like that, and I'm going to bring this over here, 0, 0, 1, 1, 4, 2. It actually has the 0.93. The more points I put on here, the better I can get a graph. So that's the original function. That's the parent function. And that's what I kind of do when I draw graphs. I draw the parent functions lightly, and then I look to see what letters they have. Well, I see I have an A value, I have a C value, I have a D value. A is a vertical stretch by 2. So I'm going to do 2 times all the Y values. C, positive 3, opposite is negative 3, so I'm going to go left 3, and D is a minus 4. I'm going to go down 4 spots. I'll do this one in red. Here I'm at 0, 0. 2 times 0, the Y value is still the same thing. I'm going to go left 3, 1, 2, 3, down 4, 1, 2, 3, 4. There's my new dot here at negative 3 and negative 4. And then over here at 1, 1, I'm going to double the Y to be at 1, 2. Left 3, 1, 2, 3, down 4, 1, 2, 3, 4. And there I'm at the point negative 2, negative 2. This point here at 4, 2, I'm going to double it to be at 4, 4. 1, 2, 3, 1, 2, 3, 4. I'm at the point 1, 0. And this 9, 3 becomes 9, 6. 1, 2, 3, 1, 2, 3, 4. I'm at the point 6, 2. And now I could start again from this point and just draw that curvy graph. Basically the same shape, just stretched a little bit. And there we go. That's the new graph. That's all I do. I take one point at a time, and I just keep on moving them and moving them. Now the last one is going to be the hardest one what to do, because of just what the parent function is. The parent function here is 1 over x squared. That's what I call this little volcano type of looking function. It's at 1, 1. It's at negative 1, 1. And I do have 2 asymptotes here. I have 2 asymptotes. Oops, let me change it to red. 2 asymptotes here. X equals 0, y equals 0, and the 2 asymptotes meet right here at the origin 0, 0. I'll put a little red dot there. That's where the 2 asymptotes meet. These graphs go through 1, 1, and negative 1, 1. So I kind of get this sort of look to it. You know, I don't have to do as many dots on this graph, but it kind of looks like that. If you want, you could put 2 1/2 on the graph. You could put negative 2 1/2 on the graph. It's up to you. My transformations. Now this one is not nearly as much. I just see a letter C and I see a letter D. A C is a negative value. So opposite of 3 is positive 3. That would be right 3. And D is down 4. And the first thing I'm going to do is move where my asymptotes meet at the origin. So it's going to go right 3, 1, 2, 3, 1, 2, 3, 4. I'm going to put a new red dot, and this is where the 2 asymptotes meet. So keep that in mind when I draw this graph, because this graph has 2 branches. I have x equals 3 and y equals negative 4 as my VA and my HA. Now I'm going to draw this graph. There's no flipping, there's no multiplying, it's just a C and a D. So this point at 1, 1, I'm going to go right 3, 1, 2, 3, and down 4. 1, 2, 1, 2, 3, 4. So I'm right here at the point 4, negative 3. And this point here at negative 1, 1, I'm going to go right 3, 1, 2, 3, and down 4. 1, 2, 3, 4. And that point is at 2, negative 3. If you want to move this dot to 1/2, 1, 2, 3, and down 1, 2, 3, 4. It's going to be there. That's going to be here. And you're going to get this graph that looks like this. Still that volcano looking graph. And there we go. That's transformational functions to a graph. Okay, we have 2 other transformations we're going to do. The first one is easier. The absolute value of a function. So what happens when we do with absolute value of a whole function? So here's a function I gave here, and I graphed it on the right. What's going to happen is that all the points below the x-axis are reflected above the x-axis. So that's what an absolute value does. It takes anything that's negative below the x-axis and makes it positive. So when I look at this graph, this part here that's below is going to get reflected up, and this part here that is below is going to be reflected up. Okay? They're going to be put above. So let's talk about the parts that's already above. So this part that's above is going to stay the same. I'm going to do it in red. This part stays the same. This part here that's above is going to stay the same. Okay, but this part between 1 and 4 that's below is going to be shifted above, and I'm going to just shift it above here. It's a point here, it's a point here. And you kind of get this little same U shape as I have here at below, except now it's above, and then this part that's here is going to be up here, and it kind of looks like this to the best of my ability. And that would be the absolute value of that given function in black. So my effect is all y values are now non-negative. They could be 0, like the points here at -2, 1, and 4. They stayed at 0, but all the ones that were negative became positive. Now the hard one to do is this one. F of the absolute value of x. And I don't think I'll ever make you graph this, but it's the same original graph as before. So what's going to happen is that all the points to the right of the x-axis, to the right of the y-axis, the right half of the graph, are reflected over the y-axis. So basically what's going to happen, I'm going to take everything on the right half of the graph, this whole thing right here on the right half, I'm not going over it in gray very lightly, it's going to be mirrored over the y-axis. So this part here I'm going to do in red now so it really stands out. This part here in red, I'm just going to copy it over the y-axis. So here, and here, and here, and here, and here. So it's going to be something like this. And you get this weird looking shape, looks like a W, but the right half of the graph is just copied over. So all the input x values become non-negative. I really only use the positive x values and I copy them over. So what I'm going to do on this page, I'm going to take graphs that I've already given to you. There's no equations for these graphs, they're just regular old graphs. And I'm going to do a transformation based on the letters I have, A, B, C, and D. So I'm going to list the transformations, and then I'm going to relocate one point at a time. Just the main points, not every single point on the graph, but just the main points on each graph, one point at a time, by doing whatever transformations I have. And it's not really that hard, I just do it very simply. So like in these graphs, I look at these are the main points, the ones I'm going to do here in blue. These are the main points. So these are the ones I'm going to move. So I look at my transformations, and I notice my transformations, I have a letter C and a letter D. C is +4, so I do the opposite, left 4. And D is -3, which means down 3. And that's all I'm going to do. I'm going to take this very first dot right here. I'm going to move it left 4, 1, 2, 3, 4, and then down 3, 1, 2, 3. There's the new dot. Same thing for the second blue dot. 1, 2, 3, 4, 1, 2, 3. This blue dot here. 1, 2, 3, 4, 1, 2, 3. 1, 2, 3, 4, 1, 2, 3. And 1, 2, 3, 4, 1, 2, 3. And it's over that blue dot. I'm going to play connect the dots. And I get basically the same looking graph that I had before, except it's been shifted over left 4 and down 3. I kind of call this graph that I made up, I call it the shopping cart. It kind of looks like a shopping cart without wheels. And if I look carefully, I think I do have a new graph that looks like it's been, the original is the same graph, but left 4 and down 3. Okay, the second one, I'm going to use a different color here, purple. It looks like I have an A value and a C value. I think A has a couple of transformations. One is going to be reflect, or we call flip, over the y-axis, over the x-axis. Getting them backwards today. X-axis. And 2 is going to be a vertical stretch by 2. So I'm just going to do 2 times all the y values. And C is negative 3, so opposite is positive 3, which means it's going to be right 3. So all I'm going to do is take these main dots in blue, 1, 2, 3, 4, these 5 main dots, and I'm going to do 1 point at a time. These basically 3 transformations, even though there's only 2 letters, because A kind of has 2. So the first thing I'm going to do is reflect it over the x-axis. So this point that's above by 3 is going to be below by 3. See? That's my flip of the x-axis. And then I'm going to take this y value and multiply by 2. So this y value is negative 3. Now it's going to be 1, 2. It's going to be at negative 6. This is 2 times the y value. And the last thing I'm going to do is going to move it over right 3. 1, 2, 3. And there's my new dot. That was my right 3. Same thing on this dot. Flip it over the x. Double the y. 1, 2, 3. Here's my new dot. So this point here that's below the x-axis, I flip over the x, is going to be up here at 2. Double the y is at 4. 1, 2, 3. I'm here now. I'll make these dots big. This one is at negative 2, positive 2, double it, 1, 2, 3. This one that's at y equals 1, flip it, it's y at negative 1, double it, y equals negative 2, and 1, 2, 3. So here are my dots. These dots are not the big ones. So here's kind of the first part. This is the second part. Third part. And fourth part. And I think that shopping cart that I had before has been flipped upside down. It looks twice as big vertically, and it looks like it's been moved over right 3. Okay, for this next one, we have 2 transformations. We have a B and a C transformation. Let me move this down a little bit, if I can. I have a B and a C transformation. And let's be careful here a little bit. So my B transformation, I don't use 2. This is a horizontal compression. So instead of using 2, I'm going to do 1/2 the x values. I always use the reciprocal. Now C, you got to be really careful, because when I see I have a B value that isn't 1, I have to do negative C over B, which is negative 4 over 2, which is negative 2. So my transformation isn't left 4, it is really left 2. That's where you need to be careful. So I'm going to do this one in pink. So I'm going to take this x value, which is at negative 6, and do half of it. So now it's at negative 3. So this is half the x value. And then I'm going to go left 2. So 1, 2. And that is the big dot of being left 2. This dot, half the x is to negative 1, and left 2 is going to be right here. This x value is 2. Half of it is at 1. Left 2 is here. This x value is 4, half of it is at 2, left 2 is going to be on the y-axis. And this x value is 6, and half of it is at 3, and then left 2 is at x equals 1. You notice I didn't change any y values, because B and C only change x values. So when I'm done, I'm going to draw this really thick and pink. I have this looking graph, and I pretty much think it does look like it's been horizontally compressed in half. It looks half as skinny as before and has been shifted over left a little bit. And this last one, a little bit different. We have a couple of things going on. I do have a B value that is negative, which means I'm going to reflect over the y-axis, and then I have this absolute value part. We'll talk about that part in a minute. Let's actually do reflect over the y-axis. So this point here at x equals negative 6 is going to be at 6. Negative 2 becomes 2. 2 becomes negative 2. 4 becomes negative 4. And 6 becomes negative 6. Notice those y values are the same as before, because it's inside the parentheses. Now this graph looks like this. So this part that I just did right now in gray is the flipping over the y-axis. But now I have the absolute value part. I'm going to do it in red. The absolute value part. That is, all y's are going to be above the x-axis. So anything that's above the x-axis stays. Anything that's below has got to be flipped up. So this part needs to be flipped up. Needs to be made positive. One thing I'm going to do, I'm going to notice the points on the x-axis. So this point here stays on the x-axis. This point stays here on the x-axis. This point gets flipped up here. This point gets flipped up here. And the other parts are already above the x-axis. So this part that got flipped up kind of looks like this in red. That's the part that was flipped. The other parts, these were already above the x-axis. I don't need to flip them anywhere. So above, flipped above, and this little segment at the end. And that would be the final result.